Yo, welcome back. And now next we solve this problem. It's about minimum equal sum of two arrays after replacing zeros. That is, they give you two arrays like one a and b and consists of positive integer. You have to replace onto zero in both arrays with strictly positive integers. So that means you must replace on the zero with the positive number which is greater from one. Yes, the minimum you can replace is one. So for if return the minimum equals sum, you can obtain, okay, or minus one if it is possible. Like the per example is 32010. That means you need to replace the third and the fifth element, while the B array you need to replace the third element. Yeah, it must be. Remember that you must be. So a possible way is to replace with this is with the 2 and with the what? With 1, 2 and this is with 4. So we got the sum of mm, okay, 12. And this is 5 and it is 11, so we need to replace this 0 with 1. Okay, and okay, so the minimum possible is 12. And the second example is 2101. That's the sum is 4, and this b array is 5. And you can see that we have 2 0. That means we need to play with minimum e1 and e1. And if we play both this 0 with 1, we have the sum of 6. Yeah, 6 is greater than 5, and we can modify the b array. So that's why we don't have a solution here. So I think the idea here is simple in this video, but I think it's an easy one. Maybe like if it's give you number one array is like 2 1 0 0 like that. This the two array is like 5 0 0 1 like that. This, for example, like this. We had this the sum before replacing 0 is like 6, and this is like 12. You can see that the difference is 6. So but at the statement said that we should replace on 0 with strictly positive integer. That's we assume that if we replace on 0 with 1, what happen? Because we want to find minimum sum. So the minimum value we able to replace here is 1. So try replace on 0 with 1, because it's gonna become the minimum sum. I don't say that's equal, but that is minimum. Let's replace first. So this is gonna become, after replace we become replace on 0 with 1, so it's become the sum of 9. And this is 14. And I can see the difference here is 5. So that we need to increase this, right? Increase this, and a possible way is to let me copy it, like 0 0 and this. With on 0 with 1, and the difference here, the diff here is 5. And we need to increase it to 5, increase at least 1 but element to 5, and the optimal way is to choose one element that we have replaced with 1 before, and plus the diff, yeah, is the 5. so it's gonna become 6, right? And now we have the sum of sum of now we have the sum of the nums 1 is the A array is 14. That's the equal. So the main idea is to replace on 0 with 1, because 1 is the minimum number you can replace the 0 with, and the target of us is to return the minimum sum. That's two array equal, so we need to try increase the as minimum as minimum as possible. Like that's why we use 1 here, and after replace on with 1, we calculate different. Yeah, so as we know that this is the, after replace with 1, this become the minimum. This is the most minimum way. So and we can achieve answer is one up to some value, so that's also the most optimal way. So that's why we can replace you can replace many, but the simple way is to replace 1 0, that's replaced by 1, then we increase is with the differences. So that's the solution, that is to find the sum plus 1 and the diff. As you are only able to replace only we are able, for example, for the case this like this I say is what I have said is about that we have a solution, but how about not like this, like this, we I have this assume that we if it was like this is the original array, and we have the sum of 9, and this is the sum of 20. As we know that this is only become because we must replace 0 with positive number, and that's the minimum is 1, so it's on it only can be increased the sum, that's become 14, and we can see that the number 1 array cannot modify, so there's no solution. We only have a solution if both array have at least 1 0, or initially is equal. Okay, sum equal. So now let's implement as sum 1, sum 2, 9. It must be long now because the limit is 10 power 5, and this is 10 power 6, and the maximum can be 10 power 11. That exists in data type. So we need to count the 0 on both array. Let's go. Okay, if sum 1 plus 1 equal to now we consider the case that return we have no solution. That's if sum 1 is different from sum 2, and we found that the minimum one, yes, okay, if sum 1 is larger than sum 2, but so we need to increase the num2 array, right? Increase the sum of num2, but there is no 0, so is not able to the same as the opposite case, right? Okay. Mm. And the last case we on the case that the sum is different and we have at least 1 0 on both array. We only find solution. That's the mean of sum 1 plus 1 and sum 2 plus in count 2 as I explained it before. Else if the array is already equal, and if the array is already equal, let's check if it's already equal, then it's the same as the previous case. The same as the previous case, right? So we need to plus it. Oh, okay. We need to do this first on both case. Sorry, my costly boilerplate. Okay. Yeah, and the answer is mean of 1 and 2. Oh. Wait a minute. Sorry, it's mass. Sorry. It's the mass. Because we only can increase the array. Yeah. So that's why I thought this is the easy one, not medium. Okay. It's an ON solution, but it can accept. Have a nice day.